Yeah, Mr. York, this is video 2, and today we're going to talk about binary. When I used to teach little kids this, we tried to get them to say the word binary, which was a new word for most of them, by getting them to say two words that they were familiar with. So if you can say bicycle and you can say canary, well, then you can probably say binary. Binary is the language of computers. There are many videos on the internet that explain that in more detail than I'm going to here. This is just trying to get you a little bit of an understanding. And to understand binary, you just need to understand that the computer only works in cycles. And within those cycles, electricity is either on or off within the transistors of that computer. And as I said, there's a video on my website that explains this really well if you want to get really into binary. But I don't feel like it's necessary to get too in-depth. Plus, I really like the one on my website. So I'll show you that real quick, just how to find it. If we go to my website, mryork.org, and of course we go to Project Lead the Way, and then scroll down past the curriculum, you will find this video.
It's a common theme throughout the modern world that everything in a computer's brain comes down to ones and zeros.
And the reason that we represent them as ones and zeros is because electricity can only be either on or off inside your computer. So on being a 1 and off being a 0. The way that you count in binary, because it is I feel like the other videos do a really good job of explaining this, so I'm not going to get into it here. But using another system of counting, such as base 10, is obvious because we've been doing it for so long. But when it comes to binary, it's not obvious. In fact, this is how it works. 0 is 0, 0. 1 is 0, 1. And of course, 2 would be 10, because we only have two numbers to deal with. If you keep counting, you might have guessed that 3 is 1, 1. And of course, 4, you have to add an extra digit, and you get to a point where you're now just adding digits in order to make larger numbers. I know it seems confusing, but that's how binary works. Here's what you need to know. Because your computer works in cycles, if I hit the letter A on my keyboard, what happens is that electricity is going to flow through my keyboard, through my computer chips and processors in a pattern. And the pattern works like this: off, on, off, 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 on. And by that 8th cycle, the computer knows that what I would like is to put an A on the screen, and it does so. Puts an A right there. A bit is either a 1 or a 0, positive or negative, on or off. If you take 8 bits and string them together, you get what's called 1 byte. Now the problem with this is that it takes, as you can imagine, if it takes 8 cycles to get just one character, think about all the code that you need to actually make a computer program run or to get your computer to do something very simple. So we're going to need a lot more measurement than we normally use in order to express something that is going to be extremely large, like the amount of bytes needed to make something work on your computer. So here's what we do. We had to go back to our friends the Greeks. And this is going to pick up probably where you left off with measurement, but probably never got any further because we just don't need anything this big except for when it comes to computers. For example, you're familiar with the term kilo. And it may not be a term that you use all the time, but if you say kilometer, or you've heard of kilometer, that's 1,000 meters. What you may not understand is that that prefix kilo is what actually means 1,000. So you can have 1,000 meters, that's a kilometer. You can have 1,000 grams, that's a kilogram. You can have 1,000 liters, that's a kiloliter. The prefix just means 1,000. So the Greeks came up with measurements for much higher. We just don't use them very often because you can literally measure the circumference of the Earth in kilometers. So we don't really need anything much bigger than that except for when it comes to computers. And we realized that if we had 1,000 bytes, that's not very much. In fact, all that does is give us maybe a current resolution picture. Pictures back in the day had less graphics, less detail, less resolution, and so we didn't need as much memory. But now we produce really high resolution graphics, and to do 3D rendered objects in your computer, you're going to need a lot more memory than this. So you're going to need a lot more bytes. So 1,000 bytes will get us like a Word document or maybe a low-res picture file. But if we take and we get 1,000 kilos, that would be a mega. Mega means million. Now we can have 1,000,000 bytes. And that might get you like a PowerPoint presentation. But if you want to produce a video file, you're going to need something closer to gigabytes. And this is the word for billion. And most of your hard drives are in this measurement, giga. But sometimes you might have a larger hard drive, and we actually get those in terms of tera, which is trillion. So remember, you can use these terms for just about any measurement. I could say that you had a megameter, but now we're literally measuring the distance between planets at that point. Gigameter, we're looking at a much larger distance than we really need in our normal everyday life. Terameter, you hardly ever hear about these terms because what are you measuring that's that big? You guys get what I'm saying? So let's take these measurements and apply them to computer and what we know of as storage or bytes. So how do we measure memory? We measure it in terms of bytes. 1 gigabyte equals about 240 songs. That's a good little marker for us. And so if you have 8 bits, that equals 1 byte. We already said that. So if I take 1,000 bytes and string them together, what do I get? I get 1 kilobyte. If I take 1,000 kilobytes and put them in one place, we would call them a megabyte. And of course, 1,000 megabytes is going to equal 1 gigabyte, and 1,000 gigabytes, which if you think about it is 1,000 billions, that's how you get to a trillion. Now, most of the aspects of your computer can be measured with these, and we haven't really gone beyond this. If you think about it, your hard drive is maybe 1 or 2 terabytes at the most. We don't usually have 200 terabyte hard drives. Not typically. That's a very large amount of information for us, just currently what we're dealing with. In the future, as we deal with 4K more and higher res graphics and other things that are more memory intense, you may need something that is larger to store it on. But for right now, that's what we're looking at. And when it comes to the RAM on your computer, as we discussed, we're still down in 16 gigabytes, 32 or 64 on your desktop as being pretty standard or normal. Anything higher than that, if you had 128 gigabytes on your desktop, that's quite a bit at this point while I'm making this video. But we're still not up to 1 terabyte. If somebody said, I'm going to sell you a computer with a terabyte of RAM, you might start to question that, because that would be incredibly expensive, and it isn't something that we consider normal right now. At some point we may get there, and you might have a very quick running computer that doesn't freeze as much, and you can work on several different types of programs at one time. But for right now, this is where we're at. 1 terabyte being the largest, and that's reserved for long-term storage like hard drives. We don't have 200 terabyte hard drives typically, and when it comes to our volatile working memory like RAM, we're still using the term gigabytes because that's as big as we have. So I hope that helps you guys to understand what's going on inside your computer, and you can now move on to video 3.